All right, I'm looking at page 6 in your examples note packet. In this question, I already graphed the points. It says, given NEWY with the coordinates NEW and Y, prove that NEWY is a rhombus. So you should have already copied down the notes into the foldable about how to prove that something is a rhombus. And so what we need to do is we need to prove that it is a parallelogram, meaning opposite sides are parallel. And then we want to prove that consecutive sides are congruent. So I'm first going to do the parallelogram part. And to prove that it's a parallelogram, I'm going to show both pairs of opposite sides are parallel. So I'm going to have to find the slope of EN. Let me fix my pen here. And I have to find the slope of WY. And then I'm going to do the other two slopes, the opposite ones, but let's do these ones first. So the slope of EN, if I count it, it's up 1, 2, 3 over 1, 2. So up 3 over 2. And then the slope of WY, 1, 2, 3 over 2, is also 3 over 2. So when the slopes are the same, I write a quick conclusion, and I say EN is parallel to WY because they have the same slope. Okay, I can do the same thing for the other sides. I'm going to mark those parallel, and then I'm going to try to find the slope of EW and the slope of NY. And so the slope of EW is down 1, 2, 3, to the right 2, negative 3 over 2. And the slope of NY is also negative 3 over 2. And so I can draw another conclusion saying that EW and NY are parallel. EW is parallel to NY for the same reason they have the same slopes. So because they have the same slope. And mark them parallel on your diagram. We can do double arrows this time. And so since we proved that both pairs of opposite sides are parallel, we can say that this whole shape is a parallelogram. So I'm going to write that next. Based on the fact that both pairs of opposite sides are parallel, NEWY is a parallelogram, and you can use a symbol for parallelogram but no other quadrilateral, because both pairs of opposite sides are parallel. All right, the next thing I need to do is actually get that it's a rhombus. So to get that it's a rhombus, I have to prove that one pair of consecutive sides is congruent. And so when I look at the consecutive sides, you can pick any two sides that share a vertex. So I'm going to do the length of EN and the length of NY. So I would do Pythagorean theorem for that. So when I draw in my rectangle, it's just like when I counted the slope. It's going to be 3 squared plus 2 squared equals c squared. So 9 plus 4 equals c squared, or 13 equals c squared. And so c equals the square root of 13. And then I can do the same thing for n and y. And notice when you count those sides, it's 3 squared plus 2 squared again. So you can just get to the end, skip the work, and say c equals the square root of 13. So we now know en equals the square root of 13. And we know ny equals the square root of 13. So we're going to draw another conclusion. En is congruent to ny. Because they have the same length. And And then my final conclusion, and I realize there's a lot of them, but my final conclusion is that NEWY is a rhombus. NEWY is a rhombus because it is a parallelogram with consecutive sides congruent. All right, on question number 9, you are given 3 points, R, H, O, and you need to figure out where M is going to be to make this into a rhombus. I've already plotted my first 3, and so to make it into a rhombus, I need to figure out my next one. Well, I know that the side opposite of HR should also be parallel to HR, and it should be the same length as HR. So I'm going to count the slope to go from H to R. I have to go up 1, 2, 3, 4 over 1, 2, 3. And so I'm hoping I can do the same on the other side. I'm going to start at O. 1, 2, 3, 4 to the right, 1, 2, 3. And that should be where M is. So we have to write the coordinates of M. M is going to be the point 2, 1. And then I can draw in those segments, and I'm just going to sketch them. Okay, in this case, they didn't say that I had to justify that this was a rhombus, but let's just make sure. If I go up 4 over 3 here, let's make sure that this one would be the same length. Down 1, 2, 3, 4 over 1, 2, 3. So if you think about doing Pythagorean theorem here, HR would be 4 squared plus 3 squared, which is 16 plus 9, which is 25. So the length of HR would be the square root of 25. But that would be true for RM and OM and HO. So they would all be the square root of 25. RM is the square root of 25. OM is the square root of 25, and HO. Okay?